Okay, this is Algebra 2-2, Unit 7B and 10. This is day 1, what you have missed. First off, make sure not to share these notes with anyone. These are your own personal notes. Sharing them with others will only hurt you because they will be trying to get me to explain when you've already earned the right to have me explain because you've studied the videos. So here we go. The first thing that I ask you to do in the top part up here is that it says turn to each of the following graphs and calculate the parent values in each graph section. So we turn to the very back of the packet, and I will just run through the very beginning of these values so that you understand how to work them. The first one is a square root transformation activity. So you're taking the square root and plugging these values in. The square root of -4, we cannot have a real answer to the square root of -4. It would be an imaginary number because -2 times -2 is +4, and 2 times 2 is +4. So you don't have any two numbers that will equal -4. So in this one we write undefined, undefined, and undefined because they're all negatives. Square root of 0 would be 0. Square root of 1, you're asking yourself what times itself will equal 1? That would be 1. Square root of 2, you would need to grab a calculator. Square root of 4 is 2. We can graph it without that point being there. So we come over, 0 on the x, going left to right, you find the 0, and then you go up to 0 on the y. At 1 on the x, we go up to 1 on the y value. At 2, we'll skip, then we go over to 4 and up to 2. We see a curved line. That is the graph for a square root. This shape in class, I believe they called it an arc. It's anything that you can describe that shape with. What is the domain and range? Domain is your x values. Range is your y values. So going left to right to find the domain, down here, do you see there's no graph? So there is a limitation. The domain does not occur down here. It starts at 0. So for your domain, you can simply write x has to be greater than or equal to 0. Because we do have x equaling 0, but it has to be greater than that. Y, the same thing going up and down. You see a limitation. There's no graph down in here, but it starts at 0. And then it goes up forever. So for range, your y values would be greater than or equal to 0. Now, I have asked that you go and do each of the graphs. So let's go on to the next page. The next page, flipped completely over, one more page, is a cube root transformation. In this graph, we're looking for the cube. In other words, what times what times what equals that number. It has to be the same number in here. Same number multiplied together to equal that. -27, if you break it down, -27 can break down to 9 and 3, which breaks down to 3 and 3. Bring in your negatives. They can all be 3. They can all 3 be negative, and that will equal the -27. Okay, so the cube root of negative 27 is negative 3. Cube root of negative 8 is negative 2. Cube root of negative 1 would be negative 1, 0, 1, 2, and 3. When graphing those, pause the camera please. Go ahead and graph that and see if you get the same shape that I do. So if you notice, this is a lot like the previous graph, that square root function, but this time with a cube root, you're able to have the negatives. So now moving over, they described this as an S shape. Again, you can have your own description. For the domain going left to right, there's no limitation on our graph. It's going clear across that, so it is all real numbers. For the range, it continues to go out and up. There's no limitation. The arrows are going on and on forever. So it is also all real numbers. Going to the next parent function. The next parent function is an exponential equation. We have a 2 here, and we've got it raised to the x power. So 2 to the negative third, you've got to remember back to the last semester of algebra. 2 to the negative third. The first step in dealing with a negative exponent is to flip it to the bottom. So it's 1 over 2 to the third. 1 over 2 times 2 times 2 is 8. So that's 1/8. This one, 2 to the negative fourth, 2 to the negative second, would end up going on the bottom. It would become 2 to the second, or 2 times 2, which is 1/4. Negative 1, 2 to the negative first, it would go on the bottom and become 1/2. 2 to the 0th power, anytime we have a number to the 0th power, it's equal to 1. 2 to the first is simply 2. 2 to the second, 2 times 2 is 4. 2 to the third is 2 times 2 times 2 is 8. So now go ahead and pause the video and graph that. We call that an L shape. Notice the domain has no limitation. It goes on and on forever that way, on and on that way. So the domain is all real numbers. The range, it never touches 0. So we cannot put that it's equal to 0, just that it's greater than 0. The next graph would be this exponential function. You notice on this one that it has a 1/2 in there instead of a 2. So with the 1/2, 1/2 to the negative third, just like with the last graph, when we have anything to a negative exponent, we have to flip it. The 1 is to the negative exponent, so is the 2, so that flips over to being 2 to the positive third. 2 times 2 times 2 is 8. 1/2 to the negative second, again you need to flip it, so it becomes 2 to the second. That would be 4. 1/2 to the negative first, you'd flip it, that would be a 2. Any number to the 0th power is 1. 1/2 to the first is just 1/2. And 1/2 to the second literally means 1/2 times 1/2. Multiply straight across, we get 1/4. And 1/2 to the third power, 1/2 times 1/2 times 1/2 is going to become an 1/8. Pause the video and graph that. And we graph the L shape just like that. What shape would you describe this? It is an L shape. I apologize on my phone. I'm not answering it. We're going to get through this. The domain, going left to right, there's no limitation. It goes on and on forever that way, on and on that way. So that is all real numbers. The range, it cannot go below the 0, but it never touches the 0. So it is y is greater than 0. Okay, we have one more graph to get through, and then we'll start answering a few questions. This is your rational expression graph. This is when x is on the bottom. So simply plugging it in would have a negative 1/4, a negative 1/2, negative 1 over negative 1 is negative 1. We cannot have 0 on the bottom. So that one is undefined. You can't have 0 on the bottom of a fraction. So 1 over 1 is 1. 1 over 2 is 1/2. 1 over 4 is 1/4. So when we come up here, the problem is we can't have a value at this 0, so we have to mark that out. That's called an asymptote. It can't ever hit that line. At the negative 4, it's a negative 1/4. Negative 2, it's negative 1/2. Negative 1, it's negative 1. At 1, it's positive 1. At 2, it's a negative 1/2, and at 4, it's a negative 1/4. So we have these funky little shapes here, but we can't cross to connect them. So our question is, what happens here close to the 0? If we have 1 over 1/2, that's the same thing as saying 1 divided by 1/2. So we skip, flip, and multiply. That would become equal to 2. So at 1/2, it comes up here to 2. That shows you that it's actually curving. So we have a curve going up. Sorry, that was not a very good curve line. And a curve going down. Here we have a curve and a curve. And so that's how the rational expression graph looks. That is called a hyperbola. Shape of the graph, in class they named it wings. The domain, here the only restriction on the domain, going left to right, it can be anything except 0. So just write x can't be equal to 0. Same thing on range. The restriction is it can't be at 0. Those lines come ever so close, but they don't touch it. That's another asymptote. So the range is y can't equal 0. Now we come back up to our notes that we filled in for the day. And we just simply discuss the shape that is caused by each of these. I'm going to silently fill these in. The square root was that arc shape. The cube root was the arc shape, but it went into the negatives with the arc as well. Now if you skip down to the bottom graph, you'll notice when n is even, we chose to show x to the second here. It is what you graphed in Algebra 1, which we call the parabola. Do you notice how it looks like the arc there? But it's around the y-axis this time. This arc and this arc have a relationship that we'll talk about later in class. In the cube, it has a similar relationship with the cube root. It is turned onto the y-axis, and it goes up like that and down like that. That would be a cube. If you have another odd, like x to the 5th, x to the 7th, very similar shape, very similar ending behavior, and any evens, x to the 6th, 4th, any of those have similar ending behavior. The hyperbola, again, was the wing shape with asymptotes here and here. Here we have the exponential equation. This one is when b is greater or is less than 1. So it is the L shape that's coming down like this. This is when the b factor is greater than 1, so we see it growing. This is an exponential growth. That's an exponential decay. The last one that I had everybody graph that just brought them back to their Algebra 1 days and helping them remember that is the linear, or when there is nothing happening around that x, and then it's just a straight line. We actually use that line in some other graphs, so I wanted you aware of when x equals y. So these bottom questions, you can go ahead and answer on your own. How do you find the domain? How do you find the range? It has to do with whether or not you're looking right, left, or up, down. Interval notation. I gave in class a drawing here. Let me just switch over to my notes that I used in class. There is the drawing. Just draw it at -3, +3, and then it comes down, touches the -2, and then goes out here forever. So when we're looking at the domain, we look left to right. It starts at -3 and it goes to infinity with this arrow tip here. In interval notation, we write that as a bracket around -3 because it can be equal to it, and then it goes to infinity. You can never be equal to infinity, so that is a rounded parenthesis. Going down with range, we look at our up, down. Up, down, we have a top value up here at 3, a bottom value at -2. So we show both of those with brackets, -2 and 3. To go over to set notation, we take these limitations and we simply write a set sign, an x such that the lower limit is -3. Because it's a bracket, we underline that, saying it can be equal. X is less than, and then the upper limit is infinity, and then the set sign closed. On your range, set sign, y such that -2 is less than or equal to y. That's because it has a bracket around it. Y is less than or equal to 3 because it has a bracket around that side. And then the end set sign. Copy down this next graph. It's just a box coming down to -1, over to 1, up to 2, and over to 1. Pause the video and try to do your interval notation and your set notation. Going left to right, the domain is restricted between -1 and +1. So we write the restriction as it can be equal to -1, it can be equal to +1. In the set notation, we write x such that -1 is less than or equal, there's a bracket, x less than or equal to +1, bracket closed, or parenthesis closed. With your range, it's a bracket, -1, bracket, +2, and then we have y such that -1 is less than or equal to y, which is less than or equal to 2. Again, we match with that. And those were the limitations on y. It started at -1, rose to 2. Go ahead and do the third one, and then check. There is the graph. It ends with an open circle down here at the lowest point. Left to right with domain. It's from -3 up to +2. So that's how we show the domain. And then the range is -1.5 to 3. So that fills in that next page of notes. In your third page, I'm wanting you to know that this HK format occurs for all functions, and this is where the H's and K's occur. So the first thing is to recognize the name. It's always by what's happening to the x. That's a square root, so this is called a square root function. This is a cube root, so it would be a cube root function. The next one, that is an exponential with the x. The b is greater than 1, so as we talked about earlier, that is a growth exponential function. And then on the same exponential function, when b is less than 1, we call that a decay exponential function. Over to the next item. If it's even, we chose a 2 in class, a 2 would be quadratic. If it's raised to the second power. Otherwise, it's just referred to as a polynomial. If it's odd and it's a 3, this should say n is odd. If it's a 3, then it would be a cubic function. And when x is underneath on the fraction, that's a rational expression. So, your next thing is to hop off of this video, go over to these links, and play with your a, your h, and your k values, and find out which one causes a reflection or flipped over the x-axis. When you see the graph that we have, and it gets flipped to the bottom side, like that, which value have you changed? Your a, your h, or your k value? Or what is it that's causing that? So take a look on those sites and see what it is. You'll have toggles that you can play with there. Now go to the transformation pages and fill in the t-charts and graph each one. All the number ones. Okay? Come in class, on description you'll write reflection. So let me do the first one with you, and then you'll do the rest on your own. So the very first one, going to these pages. You are going to plug in -4 into the square root. Again, can't have a negative inside the square root, so it's undefined, undefined, undefined. They were all negatives. Now we have a negative square root of 0. 0 is 0, there's no sign to it. A negative square root of 1, you go here first and you say the square root of 1 is 1. Now bring in the negative, so it's a -1. Square root of 2, we'd have to go to a calculator, which you may not have handy. Let's go on to 4. Square root of 4 is 2, bring in the negative. -2. So now we plot these. 0, 0, 1, -1, and 4, -2. So we see that the reflection is not really any of the A, H, or K values. It's the negative out in front of the A that causes a reflection. Please go ahead and do the first graph on this page, this number 1 on cube root, and then continue on and do number 1 on each of the pages, number 1 for exponential, number 1 for exponential decay, and then number 1 for the rational expression. Have those finished for class tomorrow. Thank you.